Hi, so I'm really excited to be here today. I'm a principal SRE at Gremlin. I'm also on the tech advisory board at Greenpeace. I love skateboarding, snowboarding, metal, punk, and breaking things on purpose. You can find me on Twitter at Tammy Butow, and you can also drop me an email if you want to chat about chaos engineering. You can find me at tb@gremlin.com. So our Gremlin team have previously worked at a lot of really cool places of all different sizes. I worked at Dropbox as an SRE manager, leading the databases team and also Magic Pocket, which is the block storage team. I was there when we did the massive migration from AWS to our own in-house block storage. I also worked at DigitalOcean on cloud infrastructure, leading a team of 33 people there, and the National Australia Bank working on mortgage broking systems, foreign exchange, and also in security engineering. And I worked at Queensland University of Technology inside the data centers there and supported the professors with all the work they were doing. So it's like a lot of different size companies. And now I'm at Gremlin and we're really small, under 20 people. And our teams also worked at PagerDuty, Netflix, Amazon, Salesforce, Google, Datadog, and more. And we're a pretty small team. So today I wanted to share with you why the world needs more resilient systems. First off, let's start by talking about what a resilient system is. A resilient system can maintain an acceptable level of service in the face of failure. A resilient system can weather the storm, a misconfiguration, a large-scale natural disaster, or a controlled chaos engineering experiment. So let's review a few industry examples to understand why we need resilient systems. First, let's start with medtech. Cardiac monitoring is now done via Bluetooth device implanted in the body and a mobile app. The patient doesn't need to take any action. Resilience of the device is the only thing that the patient actually cares about. This is what it looks like. You get a little USB device. You actually go and get surgery, they cut you open, they put the USB device inside you, then you have your smartphone with an app on it, and the device uses Bluetooth to send data for irregular heartbeats. Then that is sent to a database that your doctor can go and look at. So you can see here that the patient doesn't actually have to do anything, but if they see some sort of weird error message on their phone or they think there's some problem, they're going to get pretty worried because it's about their heartbeat and maybe some sort of issue is happening. They can get really nervous. The reason I know this is because my mum has one. And she was constantly coming to me being like, I think it's broken. Is it me? Is it the app? What's going on? So yeah, resilient systems, super important. The next one we should look at is fintech. You know, people are always changing jobs, moving homes, traveling, and more. Systems need to not only keep up, but also provide value anytime, anywhere. There was this really big outage that went for 10 hours, actually, that impacted the Bank of England, and mortgages, like the purchase of homes was not able to happen for thousands of homes on one day because it was down for 10 hours. That's a pretty big impact. When I was working on mortgage broking systems as an engineer back in like 2009, it was really interesting because you wanted to do a good job, because what you would imagine is people rocking up, like they go to an auction, they put in an offer, they're really excited, it's like their dream home, they win the auction, and then the mortgage broking system's down and they can't process their mortgage and they lose their dream home and it's all your fault. And that happened to me like many times. That's really bad. And the other thing that happens too is, like, as an engineer, you can actually get fined from the government. There's like legislation and you need to have a banking license. So there are all these problems that can happen if mortgage broking systems don't work. Next, let's look at transport tech. People are traveling more frequently for work and leisure. They need to be able to get where they need to go with no hassles. So there was this massive outage last year with British Airways. There were tens of thousands of people stranded, and it was actually estimated to cost £80 million. So that's pretty massive, just for one day. Edutech. Many students are learning remotely. They need reliable access to teachers, students, and educational material. One of my favorite schools is the School of Air in Australia. It's actually the world's largest classroom, covering more than 1.3 million square kilometers. This was actually created many, many years ago. Students would learn through radio, and you can imagine that wasn't super great. If they needed to get their homework marked, then they would actually have to wait for the Royal Flying Doctor Service to fly to their farm in the middle of the desert. The reason they can't go to school is maybe it takes like a day or more to actually get to a school, so they just can't travel to a school. So they wait for the Flying Doctor Service to come pick up their homework. They then transport it to their teacher. Maybe they have to wait several months to get their homework back to see what grade they got and to get feedback. It's just really not a great system. But now the government's giving students in the remote outback of Australia computers and access to the internet, and they're able to hop online and actually learn. So for them, it's super important that these systems are resilient and that they work well. One of the most serious ones, envirotech. People need protection from bushfires, tsunamis, earthquakes, and storms. Many of the warning systems for these disasters are legacy, unreliable systems, which is pretty scary. Australia's all-time worst bushfire disaster happened in February 2009. I was living pretty close to this bushfire when it occurred. I was living in Melbourne, and it was a really, really bad bushfire. When they did a review of what happened, it was really interesting. At the time, this is 2009, you'd think things are pretty modern, but there was no fire severity scale in place. So there was no way to actually rate how bad the fire was. There was no warning system that notified people. There was no messages sent to phones. There were no phone calls sent out to people. People just didn't get alerted that the fire was even happening. I heard a story that there was a couple, they were sitting in their home with the blinds down reading. They were just relaxing, and they had no idea that there was a fire just like meters away from their property. The only reason that they found out was because they called their friends to go out for dinner, and they were like, "You've got to get out of your house, there's a fire, like look outside." And they managed to escape. So after this really big disaster, the government got together and thought, all right, we need to have a severity scale, and we need to be able to alert people and let them know that there's a danger, and they need to get out. So they created the emergency alert system. But one of the problems with this system is it isn't reliable. It's not very resilient. It even says it on the front page. It tells you that you shouldn't trust it. It tells you there's many reasons that you might not get a text message. It tells you that maybe you might not get one because your inbox is full or it's switched off or you're not in coverage. You shouldn't rely on these messages anyway. So then you kind of wonder, like, why do we have this system? And can't we build something better? Because it's pretty important. So what do these systems have in common? The primary concern of the user is resilience of the system, in particular high availability. These systems are very important, but they're not yet resilient. So let's figure out how we can create a great future for everyone. What does a great future look like? That's really up to us. We're the ones that get to build that future. We can decide, and we can help make it better for everyone. So now, let's switch things up and start to talk about how we can create more resilient systems. I want to introduce you to chaos engineering. So what is chaos engineering? Thoughtful, planned experiments designed to reveal the weaknesses in our systems. You inject something harmful in order to build an immunity. Think of it like a flu shot. We can inject harm in hosts, containers, pods, applications, and more. What's a chaos engineer? Think of it like a vaccine research computer scientist. We're all scientists here. We're computer scientists. SREs and production engineers commonly practice chaos engineering, but really it can be any engineer in your company that does this. If you give yourself a flu shot to avoid getting sick, why don't you do chaos engineering to avoid downtime? There's actually new cancer vaccines that are being currently researched. They're looking into ways that vaccines can be used to stop further growth of cancer, to prevent cancer from coming back, to destroy any cancer cells left behind after other treatments. There's a lot of interesting work being done in this space. What if we had a bad database vaccine? What happens when the database is unreachable? Does the database fail gracefully? Does the database have reliable and trustworthy monitoring? We never really talk about this. What would we call bad database? We know that there are like the same things that seem to happen. People don't have automated promotion. There are like replication issues. We don't have proper consistency. So we know the problems, but we don't really have a name for it. We just say it's like a bad database or that's legacy. What would we call it? At Gremlin, we've run game days where we've injected harm in DynamoDB. This has been really useful. We wondered, what happens if DynamoDB is unreachable? We did a game day, and we actually learned for our own system that we needed to adjust our timeouts, and we also needed to fix our alerting. You can learn a lot from running game days. If you want to run your own, you can go to gremlin.com/community, and you can see all of our resources on how to run game days. So now, what do you need before you can start doing chaos engineering? You do need to do a few things before you can get started. There are a few prerequisites. I like to think that this is like you need your materials in place before you can get started. You can't really just jump straight in. It's going to be dangerous. The three prerequisites are a high-severity incident management program, monitoring, and measuring the impact of downtime. So let's look at prerequisite 1, high-severity incident management. This is the practice of recording, triaging, tracking, and assigning business value to problems that impact critical systems. I recently wrote a paper where I outlined how anybody can establish a high-severity incident management program in your own company. So if you don't have one, you can read that and start to set it up. Just go to gremlin.com/community. So what are SEVs? If you read the paper, you're going to hear a lot about SEVs. I use that word all the time. SEVs is derived from high severity incident. It's just a short way to be able to say a SEV occurred or a SEV is happening. And when we look at how SEVs are described, these are the key things we need to look at. SEV level, SEV description, target resolution time, and who is notified. So a SEV 0 is a catastrophic service impact, the worst of the worst. At Gremlin, we say you should try and resolve these within 15 minutes, and you should notify your entire company. That means you need to have really good messaging in place to be able to let everyone across the entire company know, because you want it resolved within 15 minutes as well, so you want to notify them immediately. SEV 1, critical service impact. We recommend that you resolve these within 8 hours. Teams working on the SEV and the CTO should be notified. SEV 2, high service impact, resolve within 24 hours. Teams working on the SEV should be notified. So how do you determine SEV levels? This is probably something you're wondering. This is what we recommend for a paid product. So if it's a 10 to 100% availability hit, and it goes for even a minute, we think that this is a SEV 0 if you have a paid product. If it's, say, a 5 to 10% hit, and it's going for over 30 minutes, then we'd say that's also a SEV 0. So what's an example of a SEV 0 that recently happened? This is SEV 0 runaway cow. I just made that name up, but I actually really think that auto-generated code names help your team remember and refer to SEVs, so it's super important. And it's really easy to just automatically give SEV a name. So this SEV was when the Nintendo Switch eShop was down, not working. The SEV started at 8:40 a.m. December 25, 2007, Christmas Day. The availability impact, 100% hit, was completely down, and the outage duration was 5 hours and 40 minutes. That was a pretty long time on Christmas Day, when everyone's just got their Switches. So they got a ton of bad press for this. Nintendo ruined Christmas. Switches aren't working, nobody can get their games. I unwrapped my Switch and I can't even use it. What is the SEV lifecycle? The SEV lifecycle starts with detection, which is where you do the alerting and paging for the SEV, using tools like PagerDuty. Next is diagnosis. This is where you discover the source of a SEV. This is usually done by the engineer who's on call, the technical lead on call. Mitigation. This is where you introduce the fix and mitigate the impact of the SEV. When you look at all three of those together, you would measure that as TTI, the total time of impact for the SEV. If you look at just detection and diagnosis, this is time to detection, TTD, and then mitigation is TTR, time to recovery. When you look on the other side, we have prevention, closure, and detection. Prevention is understanding the root cause and completing all of the SEV action items that come out of the SEV review. Closure is doing a game day to actually reproduce or replicate the SEV and confirm that your fix is reliable. So you can use chaos engineering to perform that game day. When you look at prevention and closure together, that's TTP, time to prevention. And then if the SEV happens again, you should measure that too and make sure that you're tracking it. So you would measure this as time between failures. So it might be that the SEV never happens again, and that's awesome. Or it might happen again in a week, maybe in 6 months, maybe in a year. So you'd measure it there as time between failures. It's super important to save all of the data for your SEV. The description of the SEV, what services it impacted, what the availability hit was, all of these different metrics, and then try and track them back together. You can read about how to run a game day on gremlin.com/community. I think this is a really important thing to do, especially for SEV zeros. What I always like to say is, let's make this never happen again. I think that's a very good thing to do with a SEV zero. You never want it to happen again. So then try and put some fixes in place and then run a game day to confirm that your fixes actually work. Because if you've identified the root cause, you can make that happen again. And you can make sure that you don't end up with a SEV zero. So how do you identify your critical systems? Often these are pretty similar at most companies. Probably traffic, so like Nginx, database, maybe MySQL, Postgres, RDS, storage might be S3 or maybe something you have in-house, plus any other critical services that you have in your own company that you think they're critical. I would recommend having about 5 to 10 critical systems that you identify. Usually they wouldn't be internal tools. They're going to be more customer impacting, customer facing services. The next prerequisite is monitoring. So why do you need monitoring? There's a really great book that I'm sure many of you have read, the Google SRE book, and it explains why you need to monitor. Analyzing long-term trends. That's something I've done a ton of, and it totally works. If you have all of the data of your SEVs and all of the data for your alerts, you can definitely reduce the impact. Comparing over time or experiment groups, alerting, building dashboards, and conducting ad hoc retrospective analysis. Those are all the reasons why you need monitoring. So how should you use monitoring? I recommend having a critical services dashboard. Once you've figured out what your critical services are, then you can actually start to build this dashboard. The idea of this is that anyone in your entire company should be able to go to this one dashboard where it shows the overall health of your main core product. So you can see here that we have www, API, client, and then a line for the SLA. In this example, an outage is currently occurring, which is hitting www and API, but client's not impacted. And it's super easy for everyone across the whole company to see that. You can easily make this in Grafana or some type of tool like that, Datadog. Very helpful for anybody. So what are the 4 golden signals for monitoring? The Google SRE team says that if you can only measure 4 metrics, make them latency, traffic, errors, and saturation. So if we look into that a little bit more, latency is the time it takes to service a request. For example, a HTTP 500 error triggered due to loss of a connection to a database. Traffic, a measure of how much demand is being placed on your system. For a web service, the measurement is usually HTTP requests per second. Errors, the rate of requests that fail, either explicitly, implicitly, or by policy. Catching HTTP 500s at your load balancer can do a decent job of catching all completely failed requests. And then saturation. how full your service is. Should also signal impending saturation. A really good one to have is to be able to say, hey, it looks like your database will fill its hard drive in 4 hours. That's pretty bad. Another great thing that I've seen if you have many, many hosts is to be able to roll these up into a dashboard to say the overall saturation across all of the hosts. Then you can easily see how you're going. So now let's look at chaos engineering prerequisite number 3, measuring the impact of downtime. We need to understand how SEV0s impact our customers and our business. I like to put these in 2 categories. The first is system impact, availability and durability. Durability refers to data loss. Never want data loss to happen. Customer, business impact, outcome, cost, and time. So when we look at the Nintendo Switch eShop SEV0, we can see that the availability impact is 100%. The duration in terms of time is 5 hours and 40 minutes. We don't know the cost, but we assume it's pretty big since nobody could buy any games on Christmas when the Switches had just come out. And the outcome is that, yeah, nobody can buy any games. It's pretty bad. So now let's switch gears again. We're ready to get started with chaos engineering. We've got those 3 prerequisites in place, and now we can get going. I wanted to share a case study of how Twilio uses chaos engineering. So Twilio has a product that allows you to program SMSs, you can do voice calls, all types of really cool stuff in regards to telecommunication. But they are using telecommunication providers, which can be unreliable. So they need to do a lot of queuing, and they need to make sure that customers can feel confident that Twilio is working well. So one of the services they built is an in-house tool called RateQ. And when they built RateQ, it wasn't highly available. If there was some type of issue with the primary node, an engineer would get alerted, they would be paged, then they would have to do a manual failover and promotion. So that's not very good. It would take 20 minutes, about that, to do it, and that's when someone's already awake. Imagine if you're asleep, you have to open up your laptop, get online and do it, and it's a critical service. So they really wanted to automate this. They decided to build RateQ HA, and make it that it would actually be an automated system. And not only did they want to build RateQ HA and make it highly available, they also wanted to build RateQ Chaos with 3 goals. The first one, pick a shard. Second, kill the primary. And third, monitor recovery. So they actually use Gremlin to do this, which is really cool. So they're able to have confidence that RateQ works. So how do you practice chaos engineering? First off, you start by planning your experiment. You create a hypothesis, what could go wrong? Next, you contain the blast radius. We always recommend doing it in a really controlled way. Execute the smallest test that will teach you something. Next, you scale or you squash it. So if you find an issue, job well done, then you need to move in putting in a fix, making some type of improvement. Otherwise, you can increase the blast radius until you're at full scale. It's also super important to share the chaos engineering journey widely. I recommend doing a chaos engineering kickoff at your all hands for your whole company. It's really good to let everybody know before you start doing it. And the reason it's really just in the name. People can get nervous. Why are you trying to break things? What's going on? It gives everyone across the entire company a chance to come together, to ask you questions. It's really good to just let them talk to you and, answer all of their concerns. I also recommend sending email updates and progress reports. You could just make a mailing list like chaos updates and let anybody opt in to learn and see what you're doing with chaos engineering. Run monthly metric reviews. These are really important. If you now know your critical systems, then what you can do is you can say, I want a representative from each of these 5 critical systems to come and do a monthly metric review where we look at our key metrics, like say on-call load, number of SEV0s, SEV1s, SEV2s, and then each month you would compare and make sure that you're seeing improvements, and if not, you would set action items to try and make sure you do see improvements the next month. Another good thing to do is deliver presentations internally. it's really cool to be able to say, hey, like, these are the chaos engineering experiments we ran on this service. This is what we learned from it. These are the improvements we made. And then other service teams can learn too. And I think it's really good to start with critical service teams, but really any service team within your company can do chaos engineering. The big thing is don't surprise everyone. So what is Gremlin? Gremlin provides a full suite of tools to safely and securely run chaos experiments in production. There's a range of attacks that are built in and ready to run on Linux. There are 3 different types of attacks. The first is resource. So this is all about resource consumption: CPU, disk, I/O, memory. Next type is state. So process killer, shutdown, time travel, and then network: black hole, DNS, latency, and packet loss. So all of these attacks are already pre-built in now. So now I wanted to do a live demo of chaos engineering, get to the fun stuff. I've created a Kubernetes cluster, and I'm using WeaveNet here with a demo microservices application. So if you go to gremlin.com, you can actually see a tutorial I wrote, so you can do this yourself afterwards at home. The cluster has a master with 3 nodes. You could do chaos engineering with a simple bash script like this. This is going to cause a lot of chaos. But it's not a very elegant way to do chaos engineering, right? Like, there's a ton of ways to break things on purpose, but there's also like better ways to break things on purpose. So one way that you can do it with Gremlin is you can create a Kubernetes Daemonset. So here I've got a little bit of a snippet of the Daemonset YAML file. And I'm going to be impacting the namespace called SockShop, which is the WeaveNet microservices demo app. Then I just create that, and it'll be done. So next, if I went to get pods namespace SockShop, you see that Gremlin is there up and running. We've got the pods. So next, you can run an attack using the Gremlin control panel. This is what I'm going to do now. So you can see here, this is the microservices application that's running. This is actually the second node that I built. This is Gremlin here. So I'll just show you how easy it is to create a chaos engineering attack. I like to start with CPU, because to me, CPU is like the hello world of chaos engineering. If you go to resource, then CPU, you can see the default here is, let's hit 1 core for 60 seconds. We always recommend that you choose an exact host rather than doing things randomly. It's just much better to do controlled chaos engineering. So next, let's select the host, and then we'll click create. I could also impact a specific container or pod if I wanted to. So now the attack's going to run, and you can see here it's currently running. I can click here and I can see the logs. If I go in here, I've got HTOP up and running. You can see the Gremlin attack has started to run. It's a little bit small, but it does say there. You can see, because it's HTOP, it'll show you we're hitting 1 core for 60 seconds. Pop this open, I'll also be able to see more detail. And then over here I have Datadog. So I'll be able to see the attack being performed on the host in Datadog as well when that pops up. And then over here you can see that it says we actually have a Slack integration for Gremlin. So you can see that the CPU attack has started, and then when it's successful, it'll also notify you in Slack too. And this is all part of that idea of it's really good to notify your entire team, your engineering team, anyone in your company that the chaos engineering is occurring when it's occurring, because then they just know what's happening. It's so much better. So let's just look here. All right, so yep, so see it's just gradually changed color a bit there. This is it here. And we can see it's at 43% there. And yeah. And it's successful, so it's successfully completed that CPU attack. So that's just a quick hello world chaos engineering demo for you. So let's review the path to chaos engineering. First, you want to start with having a high severity incident management program. Then you want to make sure that you have monitoring. You want to measure the impact of downtime. Then you want to do chaos engineering. And after you've done chaos engineering, you want to start making and measuring your improvements. And then you go in this loop where you're doing more chaos engineering, you're making and you're measuring your improvements, and you just keep going. So how do you make improvements? This is often a big question, right? So you've done all of this chaos engineering, you've started to cause attacks, you're doing a range of different types of attacks, you're noticing where the weaknesses are in your system. How do you make improvements? I like to call this the 6 Bs. So there are a number of different ways to make improvements, but this is how I like to categorize them. The first is build. You can build a new system. It's always possible. You can improve your existing system as well. You can borrow. You can use open source code. You can use open source software, but it's also good to contribute back. That's why I like to call it borrow. So if you're doing chaos engineering on open source tools or software, you might find a weakness, and maybe it impacts other people, not just you. So then you'd be able to go and say, hey, like I found this issue when I was running my chaos engineering experiments, here's a fix for it, and you contribute that back to everybody else. The third one is buy, so using third-party systems. Brush up. This is where you have things like game days, training, fixing monitoring and alerts. It's actually super common that chaos engineering will help you figure out that your monitoring alerting is not very good. This is very common. I've seen it happen all the time. Usually there are issues with thresholds. Maybe somebody got paged at like 3 a.m. in the morning and they didn't think that the page was really great. So when they were kind of half asleep, they changed the threshold, but then you go and look at it next day and it's like, what did they do? That happens quite a lot. So it's actually really good to make sure that you're reviewing those. And chaos engineering and game days is a great way to do that. And by training, I mean on-call training. So we constantly have new engineers joining our teams, and there's a lot of knowledge that needs to be shared around. And it's hard if maybe only one person has that knowledge in the team. Say you've got someone that's been on the team for like 5 years, they've always been on that team and they've never moved to anywhere else, and then new people join the team. A great way to do on-call training is to actually get into a room and say, hey, let's go through a SEV that recently happened. You can actually pull that details up, because if you've done these prerequisites for chaos engineering, you'd be storing all of your SEV data inside a system like Jira, Pivotal Tracker, something like that. And then you would also have automated dashboards to show you your SEV information. So in this on-call training, you could pull up the SEV details from Jira, and then you could go through and say, let's actually go through and explain how you would solve this SEV if it happened again. And I'll also show you the fixes that we put in place to make sure that it doesn't happen again. But just so you're aware, these are the past SEVs that have happened for this critical service in the last 6 months. That's a really good thing to do for training. Break. Chaos engineering and failure injection. And then the last one, be gone. It's my favorite. Decommission systems and delete code. So if you're doing chaos engineering and you really go like, oh, this is actually super bad, like we just need to get rid of this code, this is dead code, or it's just causing major problems, or maybe there is some type of legacy system that's been left behind. It's kind of like you open this door and you're like, whoa, what is that? And then you might need to just decommission it. That's a good thing to do. So always measure your improvements. Tell your before and after story with metrics. The world needs more resilient systems, and you can create these more resilient systems. I hope you'll join us on this journey. You can go to gremlin.com/community. We've got a ton of resources there for you to learn more about chaos engineering, game days, SRE and production engineering practices. We also have a Slack that you can find, gremlin.com/Slack. And we've got over 400 engineers who have joined the Slack from all over the world who are practicing chaos engineering or just learning more about it. And I'm also teaching a boot camp tomorrow, which is going to be super hands-on, and it's a full-day boot camp. So if you want to really get stuck into chaos engineering, come along tomorrow. Thank you so much. It was great to be here.